Water. It's one of the most vital natural resources that exist to us. Simply put, we cannot survive without it. Although water is not only for our exclusive use, we must remember that water is a shared resource. We share it among the other millions of living species here on our planet. One group of living organisms are especially important in the cycle of water. If you haven't guessed it already, it's plants. Water is critical in the growth, photosynthetic, and vascular processes that occur in all plants. Water in all its abundance may seem limitless, but unfortunately that is not the case. We are beginning to see a strain on our precious resource. Canada alone is estimated to hold 20% of the world's fresh water, but only 7% remains available for our renewable use. Much of this water drains to the north in the Arctic, leaving water resources in southern Canada often heavily used and overstressed. We need to find ways to conserve the water that's available to us, and also need to make an effort to stop the overuse, pollution, and disruption that we cause to the water cycle. In what is considered to be the water crisis, it is predicted that by 2025, 2/3 of the world's population will suffer from water shortages. We need to act now. Coming back to our green friends mentioned earlier, they need this water to provide us with many irreplaceable processes that naturally occur, but they too use a lot of this water. What if we could find a way to reduce their use, but continue to provide them the vital resources and nutrients that they require? Plants around the world depend on the global hydrological cycle, which in its basic form represents a closed-loop system. What if we recreated the cycle, but on a much smaller scale that can be used almost anywhere to provide plants with water and nutrients? No additional water needed, just a definite amount that can be renewed for continual use. Administrators, staff, and students, our group would like to present to you the Aqua-Greenhouse project. Let's take a look at how this project can be implemented to decrease York's water footprint and how we can contribute to being a greener, more sustainable world.
Being one of the largest universities in Canada, it is no question that York University requires a substantial amount of water for its campus. In fact, the average Toronto household uses around 300 cubic meters of water per year, whereas York University uses somewhere around 200,000 to 300,000 cubic meters of water annually. Although this is expected, universities need water for many functions, such as keeping facilities running, landscaping, residential use, and especially gardening. Gardening and landscaping requires a continuous source of water, along with fertilizers and pesticides. The Aqua-Greenhouse project helps to minimize not only water required, it completely eliminates the use of additional water and fertilizers. Keeping track of York's water usage is important, but we must remain committed to helping the environment at every step we have as well. There are many solutions available and are currently being developed to help curb water shortages and overconsumption, such as policy reform, mechanical innovation, and advocacy. Among these solutions is one that is making its name in horticulture and presenting us with a unique opportunity to create a small-scale, sustainable ecosystem that benefits plant growth. It's the simple idea of letting animals and plants thrive in harmony, like they do in natural ecosystems around the world. In case you haven't heard this already, it's called aquaponics. This system can actually be witnessed functioning in large-scale ecosystems in many parts of the planet, including the river streams containing salmon in Western Canada, as well as the ecosystems along the Amazon River in South America, and even the jungle lakes and streams in parts of Asia. But how can we replicate this process here at York University? And how does this benefit us, you might wonder? First, we must briefly explain what aquaponics is, and how this serves as the key function of the Aqua-Greenhouse project.
Aquaponics is a system that allows us to grow plants without the use of soil, minimizing many added costs to gardening that we may otherwise incur. This system makes use of fish waste, turning it into fertilizer for plants located downstream. In terms of the aquaculture we are going to use, we chose Mozambique tilapia, as it is a great generalist tilapia species. It has a fast growth rate, appealing taste, and it is very hardy and disease resistant. All of these factors make the Mozambique tilapia a very desirable fish to use. The fish are best bought as fingerlings or fry for two reasons. One, they are much cheaper to buy, and two, they produce lots of waste when growing, which means more nutrients for the plants to utilize. In conventional gardening, a continuous supply of water is always needed at the site to feed the plants. Aquaponics allows us to isolate only a small portion of this water supply to be used for the entire duration of crop growth. Using this water, live aquaculture such as fish are added, releasing ammonium nitrates into the water that are later treated by bacteria in a biofilm. This cycle of water being utilized by the fish and then processed by plants creates a closed-loop system of water, where minimal water is lost only through the evapotranspiration of plants. The system cleans itself and converts ammonium nitrates into nitrogen that is vital for plant growth occurring in the greenhouse. The aquaponics system is proven to be an eco-friendly process in that it is organic, sustains itself, and does not require the use of any harmful chemicals. For these reasons, we believe the Aqua-Greenhouse project will make a great addition to the York University Kiel campus. The Aqua-Greenhouse project has many benefits and can be used for many purposes even outside of the greenhouse. There's even the possibility of using the nutrient-rich water to feed campus lawns and reclaim it through artificial aquifers that will transport the used water to a cleansing system and then fed back into circulation. The implementation of projects like these are important in building our knowledge about sustainable systems. The Aqua-Greenhouse project is a symbol of new things to come and brings with it many benefits that go beyond our campus. Now, let's examine some of the community benefits associated with implementing such a system.
The Aqua-Greenhouse is a great addition to the York University campus, as there are many benefits to both students and the surrounding community. Communities located around York University can experience barriers to healthier food choices, and often can't make time to tend to a community garden. Some of these communities need the food to be brought to them, and this is where York University can play an important role in its neighbors' lives. While producing clean, sustainable vegetables in our gardens and greenhouses, we can also partner with food justice organizations such as FoodShare to deliver our products to communities in need. A great benefit of the Aqua-Greenhouse is that it can run all year round, whereas Ontarians without a greenhouse remain restricted to only a few months in the summer for plant growth. Ensuring food security in our communities and on campus is critical. Through this project, we'd like to empower our neighbors as well as our students. The Aqua-Greenhouse can also serve as a learning center for students interested in plant growth, microbiology, and even those interested in starting their own sustainable systems at home or in their communities. Through projects like these, York can become a leader in green technology and help make a positive impact in the community as well as the environment. As environmental students, we look forward to implementations of new systems and practices that continue to make our lives greener and bring us closer to nature. We are hoping this project will appeal not only to administrators but as well as students who are eager to learn more about sustainability. So, York, will you be the next proud owner of an aquaponics system?